Good morning. Welcome to the Field Crops Virtual Breakfast. We're really happy to have you here with us. This morning, we have Wild Weather for Hay by Dr. Kim Cassida. She's here to tell us all about how to fix what just happened, right? Is that what you're here for?
Of course.
Of course. All right.
Well, I was told when I logged into the group this morning that I had an extremely timely topic, and I must have some kind of insider information to know what the weather is doing, which is not really true. But we have had some really crazy weather going on for our forages in actually recent years, not just recently. I just want to start out with making a few comments about forage yield and persistence in general, because over the long term, the erratic weather we've been having has a really big effect on our forages because they cause stress on our plants, and stressed plants don't yield well. And too much accumulated stress can actually kill them. So what we have been seeing over recent years is everything coming at us, it seems, rapid fire, no sense. We have heat waves, we have late spring cold snaps, we have had lack of snow cover in the winter, we've had flooding, we've had drought, and it seems like we're having all of these in rapid succession. This picture that I'm showing here, I took in one of my fields yesterday. And on Monday, I was looking at forages that looked really drought stressed. Um, all of these things are really hard on our perennials. That's the difference between managing a perennial crop over an annual, in that we do see legacy effects for all these things that keep happening over a period of years. And sometimes it's just too much for our forages. One question that we're getting a lot of this year has been about weed invasion in forage stands and hay stands, and that's not really an issue for today's talk. But this is another symptom of this overall weather stress, because when the forages are weak, the weeds will invade. And I believe Erin Burns has talked about that in some of her um, in some of her talks. So how do we try and cope with that? The best thing we can do there is to help manage our forages to keep their roots as healthy as possible. And that means allowing enough time between cuttings so that we can regenerate their root nutrient reserves, so they have a bank account to grow back from. We need to make sure that we are maintaining recommended soil pH and fertility, and I've talked about that in previous installments of Virtual Breakfast. And we need to do things that help reduce traffic over our stands, and I'll be talking about that a little bit here today. So the first thing to understand in regards to getting our hay dry is just what are the stages in getting hay dry. The first step happens in the field after you mow it. And there are 3 stages to that drying process. We cut the forage, it's usually about 80% moisture at that time. And once we separate it from the ground, it can no longer bring water up from the ground, but the plant doesn't actually know that it's dead yet. And it is still responding to light falling on it and conducting photosynthesis. Photosynthesis will lead to water being pumped out of the stomata of the plant actively. So you can see in our chart here, this is actually the fastest drying phase of the plant, where we're having this active photosynthetic drying is pushing water out of the plant. And this will occur up to about the point where you get to 60% moisture. The next step is driven primarily by evaporation, where we are continuing to move water out of that plant. And then finally, the phase 3, also driven by evaporation, but by this time, we're down to water that's very tightly held in that plant, and it's harder to get it out of there. So the things that can really drive these 3 phases include any weather conditions that promote photosynthesis in phase 1. So we want to have bright sun. And in phase 2, that will also help to have good drying conditions that encourage evaporation. 2 things that I'm going to talk about in a minute that really help in that stage, in those two stages, are conditioning of the hay crop and how you form your windrows. When we get down into that phase 3, really that is being mostly pushed by weather and inherent osmotic and cell forces in the plant to get that last little bit of water out of there. Usually when we get into that phase 3 drying, our leaves are dry at that point and our stems are not. And this can lead to excessive amounts of shatter when we are doing things like raking and managing that crop. Our goal is going to be to get our moisture down to less than 60% to stop our respiration before we get into the first nightfall. Because at 60% is where the plant stops burning sugar that's inside the cells. So how can you help speed this process up? Using a hay conditioner is a major factor that can help speed up the drying of our stems in particular. We have two kinds of conditioners that can be installed onto a hay mower. The most common type in Michigan is probably the roller conditioner, and we use these for alfalfa and legumes and for legume grass mixtures. Can also be used on pure grass. But it's a must to use this type for any kind of legume. And our aim here is to have the stems crushed at least every 2 to 4 inches along the stem length, but have no more than 5% of the leaves bruised. The conditioner is intended to crush the stems. We're not trying to mash the leaves because if we mash the leaves too much, that will increase their shattering potential later on in the drying process. So in order to get this right, we want to set the roller clearance slightly smaller than the stem diameter of whatever type of forage it is that we are harvesting. The second type of conditioner is called a flail or impeller conditioner, and this uses rotating fingers to scratch the surface of the forage crop. And this type of conditioner is for grass only. You should not use this on legumes or alfalfa because they're very good at stripping legume leaves off the stems. And what we can find in general is that conditioners will, well, I shouldn't say reduce drying rate. I should increases the drying rate because it makes it faster. So you can gain about 4 hours of time compared to no conditioning during the phase 1 part of the drying cycle. The second thing that's very important to manage our drying is to lay a wide swath in the field when you mow. And this is a difference compared to what we recommended, say, maybe 20 years ago. We now know that when you lay that forage down in a wide swath that covers at least 60 to 70% of the mower width, we are greatly facilitating that photosynthetic drying because we're increasing the surface area of the forage that's exposed to the sun. And that is going to drive the moisture out of it much more quickly than if we put the forage down in a narrow swath or a windrow. And here is some data from some work in Wisconsin showing the difference between a wide swath in the blue and the red swath in the brown. And what this is showing for people who are audio only is that the wide swath is drying much more quickly in the first 12 hours than the narrow swath is. And the result of this is that to reach 65% moisture, which would be where you might put it up for haylage, it was 5 hours faster to get to that point with the wide swath. And if you're trying to get down to dry hay moisture, it was 24 hours faster in this instance to use the wide swath over the narrow one. Another factor here is you should leave at least a 3-inch stubble to help hold the swath up off the ground. And that helps prevent wicking of moisture from the ground should the ground be wet, like it certainly is right now. It's also important to understand that hay continues to dry after we bale it. This is why it is so important to put it in the bale at the proper moisture, because that sweating action on the moisture that's in it at baling will cause heating, as microbes in that material are munching on that hay. So typically for about 2 to 3 weeks after baling, you have the potential for that hay to be heating the more moisture that's in it, the more heating you're going to get. A little bit of heating might actually be helpful in helping to drive off that last bit of moisture. But if you have too much heating, it's going to damage your protein. If our temperature in the bales gets up over 125 degrees, we are risking protein damage to our nutritional value. And if we get up in the 150 degrees Fahrenheit or greater range, now we're in the range of risking spontaneous combustion. So when you have hay that's put up at recommended moisture of less than 20%, typically we don't see a lot of heating there. But if you get up around 25% moisture, you are in the protein damage risk. And up around 33 or in the 30s, you're getting close to the fire risk. One of the things you can do if you've put hay up in bales that you think might be a little bit questionable is to stack it in a way that allows air circulation around those bales while they're in the sweating phase, and that helps dissipate that heat away from the bales. The safe baling moisture depends on the bale shape, size, and density. The reason for this is that during that sweating process, the greater the surface area of the bale relative to its volume, and the looser the hay is packed, the easier it is for that moisture and heat to get out of that bale. So typically we find that our small square bales, which are low in volume and not usually packed very densely, can be baled at the highest moisture content. So we would like to have them less than 20% when we bale them. The next level would be our large round bales. We have a threshold of less than 18% safe baling moisture for those. And our large square bales, which can be packed very tightly and don't have a great surface area, have to be the driest. So we want to have them at 12 to 16% moisture before we put them in the bale. I want you to consider baleage. Now, a lot of people around different parts of the country are saying it's getting harder and harder to get hay dry. This is not unique to Michigan. And this is, as our weather gets more unpredictable, this is probably not a problem that's going to go away. And you'll hear people talk about hay in a day. Usually when people are talking about hay in a day in the humid parts of the country like the Great Lakes, they are not talking about dry hay. They're talking about wet hay or baleage or haylage, because these can be put into the bale at 50 to 60% moisture instead of 20% moisture. And in the Great Lakes region, if you have good drying conditions, it is possible to get there in one day, which I'm not going to say never. Probably somebody's put up dry hay in one day, but it's darn hard to do in this part of the country. Now, the downside of putting up baleage or wet hay is that this is not marketable for all types of livestock or for all farm scales. So if you're putting up hay for the horse market, you're not going to find much marketability for baleage. And also, small farms have trouble with baleage because you need to have enough livestock to finish eating a bale before it spoils. So if people only have a few animals, this is not feasible. What happens when we rain on our hay? Basically, the losses are proportional to the amount and timing of the rain that falls. When the rain falls immediately after the hay is cut, there may not actually be little impact because the plant still has its waxy coating. It's basically waterproof in phase one. But if that rain falls during the mid to late stage drying, it can cause up to 50% dry matter loss. And these losses occur through direct leaching of water-soluble nutrients like carbohydrates and minerals. Water-soluble carbohydrate is lost at about 0.1 percentage point for every quarter inch of rain, even in phase one of drying. We also see loss of leaves through direct rain impact, and because now we need to handle the hay more to get it dry. You can see mold and post-harvest heating, and these will result in increased cell wall concentration and decreased digestibility. That increased drying time means more handling. It means it's in the field longer. It might rain on it again to increase the risk, and there's more cost involved. And if it takes longer to get that hay dry and out of the field, that probably means you'll be driving on your regrowth more than 5 days after you mowed the crop. And this increases the traffic damage to the regrowth, especially in alfalfa. So people are always going to wonder, so there's rain in the forecast. Should I wait or should I just go ahead and cut it? You need to balance a couple of things to make that decision. So understand that advancing maturity of the hay crop may actually impact your forage quality more than the rain, depending on conditions. So we'll see that neutral detergent fiber in that hay will increase 0.3 to 0.9, almost a full percentage point per day of maturity that you wait, particularly in the first cutting. So if you say, for example, if you had to wait a week to avoid rain, you have got almost 6 to 7 percentage points more NDF in that crop than you would have had if you cut it when it was ready. And that is a huge difference in nutritional value of that hay. On the other hand, the rain could potentially increase the NDF by 2 to 6 points, depending on how the rain falls. So it's definitely a balancing act. One thing that you can consider doing that can help give you an insurance policy is using a reduced lignin or a high quality type of alfalfa. What we find with these is they're pretty well documented that they actually mature more slowly than regular alfalfa, which gives you a little bit of extra time to harvest them without getting as big of a drop in your nutritional value. So basically, if you wait to harvest the extra week, you've increased a little bit of yield. But if the nutritional value of that reduced lignin or high quality alfalfa is lower to begin with, you will end up at the same point as if you had a conventional variety. And the price of those varieties has come down to make them a little bit more feasible from an economic standpoint. Now, when you're making that decision, this is where you need to have a good weather forecast. You're going to be considering a couple of things. And one of that is, do you have a grass crop or alfalfa? Grass is more tolerant of rain than alfalfa is. You're going to have more damage on a legume crop if it gets rained on than you are typically with a grass. You need to estimate how dry is the hay going to be when it rains. Is it going to be fresh cut hay, less damage, versus it was almost ready to bale, lots of damage? How much rain are you expecting and how long is it going to rain? A full day of rain like we had yesterday is going to cause much more damage to the hay than a quick rainstorm that passes on. And also you need to consider, do you have a market for the damaged hay? If you have a way to sell it to perhaps beef cattle, as opposed to a higher quality market, then it may be worth the risk to just go ahead and cut it. What time of day do we want to cut? I get this question a lot. People read things from the West that tell them they should cut their forage at the end of the day because they accumulate more sugar over the course of the day, so the water-soluble carbohydrates are greater at sunset. We do not recommend that you do this in Michigan because we are humid. And if you cut at the end of the day in Michigan, you will not get to 60% moisture before dark comes. And that means that you have active plants through the night, burning that extra sugar by respiration, because photosynthetic drying, that fast drying curve, cannot occur in the dark. So if you cut your hay in the evening, that is probably going to increase the total amount of time you have it down in the field before it's ready to put up. So in Michigan, cut it in the morning. Please know your moisture content. This has always been important, but it's even more important than it used to be. A lot of people just visually estimate whether or not the hay is dry or not, but that can be deceptive. Also understand that your moisture is not going to be uniform across the field. So there are various tools that you can use, like a Coster tester or a microwave or hay moisture probe, that you can test the material in a few test bales, or even from the windrow. But the easiest way to do it is to put a moisture monitor on your baler. And if you don't have a built-in monitor on your baler, you can get retrofit units to put on almost any kind of baler that will give you instant results as you're baling that hay. And lastly, I want to say a couple things about hay preservatives. These probably are going to become more of a thing in Michigan with our current weather patterns. Keep in mind that hay preservatives are safe for all animals to consume. We do have marketability issues with some hay markets, such as the horse hay market, where they really don't want to see preservatives on the hay, but then they also don't like moldy hay. So it is safe for horses to eat these materials. So we have sodium and potassium carbonate salts. These actually are put on the forage at the mowing stage, and they actually act as desiccants to help the hay dry faster. And these are effective on legumes or grass legume mixtures, but we don't typically use these on pure grass because they just don't work very well on pure grass. The second type of preservative is the organic acid type, and these are put on at the baling stage. You can see in the top picture, there is a small square baler where a organic acid applicator has been retrofitted onto this baler to apply the acid as the hay goes into the baler. And these allow baling of hay in the range of 18 to 30% moisture. And they work by inhibiting microbial growth in the sweating phase. They do reduce short-term heating, but they don't do much after that. They don't have a long-term quality effect over the whole storage life of the hay. And these are typically applied at 1 to 2% of the hay fresh weight. It's usually a propionic or acetic acid or a mixture of those two. And you do have to be aware that these are very corrosive to equipment unless they are buffered with ammonia. So there's a few tips on ways to try and deal with poor drying weather.
I want to thank everybody for attending. We're going to take questions now. We've got some stuff in the box, but Marty, do you want to talk about white mold first?
He might be
I
driving
think
in,
Marty
Sarah.
had to drive.
Oh,
He
okay.
was driving in. He said he had to drive in after this.
Okay. Any other specialists who want to share ahead of taking questions?
Chris had something she wanted to share, Sarah.
So a couple weeks ago, my colleague from Canada, Jocelyn Smith, was on talking about, I call it the Nova Scotia effect, where we've had some resistant corn borer populations found in these isolated areas like Nova Scotia, which is an island, where a single trait corn has been planted for too long, probably, rather than going to the stacked trait packages. We've also got another site in Connecticut that's kind of like an island. It's an area surrounded by urban development. And just this week, there's been another interesting thing found very much like it with southwest corn borer. So, southwestern corn borer. This is not a pest in Michigan. It is not European corn borer. It's a native species, but it does damage just like European corn borer. And this is the location. Pat Porter may be on. He often attends the breakfast, but this is Antelope Wells, New Mexico. You can't make these names up. And this is a picture that he took in the field. This will be relevant in a minute. This is another picture from Dr. Porter from yesterday. These are corn stalks with 1 to 7 larvae per plant. This is BT corn. And it's affecting Cry1F corn, a single trait corn. Cry1F corn was planted there for a very long period of time. So there's Cry1F issues, also Cry1A and Cry2. And I mean, it appears here that every single stalk has multiple larvae. Here's a Google Earth shot that I plucked out to show you this location, just to make this point. These are isolated pivots, almost like islands in the desert, with surrounded by mountains that you saw in the previous picture. And for many years, single trait Cry1F hybrids were planted. probably past when they should have been, when stacked traits should have been introduced. And now you have field failures, not just of Cry1F, but Cry-AB and Cry2 proteins. So I'm just trying to make a point here that wherever you perhaps have isolated areas, and it doesn't have to be an island like Nova Scotia. It could be the northern part of Michigan where there's growers who are kind of isolated in woods, essentially. Those are the kind of places that we need to be looking for these BT resistance cases, if they are going to happen, where again, single trait hybrids were used for a long period of time. You know, we're in the north. You don't necessarily, as further north you go, there's fewer hybrid choices. You guys' eyes out there are what we need to identify these cases early. So I just want to show you that dramatic picture where the landscape is essentially an isolating thing. It doesn't have to be an island. In addition, Western bean cutworm is flying. It's flying earlier than we've ever seen it. We've got some fields that are actually over threshold from earlier this week, the earlier we've ever seen this. And Western bean is also a little bit at risk because the only protein against it now is VIP. And so you essentially have single trait hybrids out there for Western bean cutworm. So we have to be looking and managing this pest very carefully. That's all I
Thank you,
got.
Chris. Any other specialists would like to share?
Sorry, I'm here now. So just really quick, we're certainly entering the period of risk for white mold, which is beginning of flowering, R1 through to R3, beginning of pod development. So just be thinking about if your fields are at risk. There's an article that I put in the link there too, just to have a look at. You could run the Sporecaster app to assess risk as well as another sort of indicator. But certainly considering field history is really important. And then if you are going to spray a fungicide, make sure you use a fungicide that will actually work on white mold. And we have a list at the Crop Protection Network and in that article that you can look at for that. And then onto tar spot in corn, we found it now. It's been confirmed in Branch, Shiawassee, Saginaw, and Jackson County at pretty low levels. So I wouldn't panic yet. But the key here is to be out and scout. There's still time. And I would certainly wait as much as possible if we were going to make a fungicide application. Most years, the best ROI comes from a fungicide application between R1 and R3 in corn. There's some exceptions to that, but early vegetative applications don't tend to help very much for tar spot management. So that's all I have. Thanks.
All right, thanks, Marty. We're going to take the questions for Kim. So here we go. Kim, are you ready? Here's a question about, is there a recommendation on timing to turn the alfalfa swath using an inverter to increase drying time?
Yes, typically we would want to do our intervention for whether you're using a rake or an inverter. That would be done when your moisture content's about 30 to 40% for the most effective use of that.
Okay, thank you. Jason asks, so I do small square alfalfa 9-foot cutting in Huron. We got an 8/10 of an inch yesterday. Should I cut my hay today before it rains on 1st of next week, or wait till after and see what happens on Monday and Tuesday?
Well, I think that my answer to that question would be the classical, it depends, because I would need more information about how you're marketing that hay. If you are marketing to a market where forage quality is paramount, remember that you're losing forage quality every day that you wait. Although we are in the regrowth cycle on alfalfa, which means that it's not dropping as fast as it does during the first cutting. And then look at the probability of rain in your area. Is it a pretty sure thing that you're going to get some rain, or is it just a possibility of showers that might or might not hit you? Those are the sorts of things that you have to weigh when you're making that decision. And I would say that for anyone who is in the high rain belt, if Jason only got 0.8 of an inch, so his ground is not super wet. I got 4 inches at my house, and I would recommend anyone in my area probably shouldn't be cutting any hay today because the ground is probably still got standing water on it.
Well, that leads into Teresa's question. She says, is there any data to show any advantage to use a tedder to have a narrower swath and allow ground to dry and use a tedder to spread out onto the drier ground after the ground's dry?
That actually has been looked at over in Wisconsin, and not so much with the tedder in mind, but just looking at the narrow versus wide swath question is, are there conditions where the narrow swath is better because it lets the ground dry out when you go and rake and move the hay back onto it? And basically what they found is that you lost so much of the photosynthetic drying that it really didn't help to do that. So I would think that using a tedder could work, but you would want to spread the hay out as soon as you made that narrow swath. I do know people who will use a tedder if their mower is putting the hay into a narrow swath or a windrow, because some mowers, that's what they do. They'll actually go right behind the mower with a tedder to spread it out so they get the wide swath. And that is still considered to be better than trying to use a narrow swath. It's more about getting the sun beating down on the surface than it is about the what's happening at the bottom, as long as you're not dropping the hay into standing water.
There's a couple things in the chat from Manny. He's talking about corn and soy in when they get too much water. So you might want to look at that if that's your deal. And then Lyndon has some new irrigation recommendations in there with a link. So if you're an irrigator, check out that recommendation from Angie. I don't see any more questions. So giving this a second, but I think maybe we're ready to wrap up.
Sarah, this is Marty again. Just something else to add. These heavy July rainfalls are perfect for Phytophthora root rot in soybean. So I guess just pay attention to what's happening in your field. Get a sample into the diagnostic clinic if you'd like to get that confirmed. We certainly have seen loss of some of the resistance genes like RPS 1C and K that are widely deployed for resistance. So look up the variety that you have planted and maybe think about that for future years in terms of seed selection.
Thanks, Marty. All right. I think we're gonna call it a day. So thank you so much for joining us, and I hope you have a great week.